This is my setup for the 555 timer and its astable mode. In the astable mode, the chip generates a continuous wave of pulses of high and low voltage in the output pin, which is going to be visualized here through this LED connected in series to a resistor to prevent too much current from flowing through it. Power this on, it should begin flashing. The LED is blinking, which means the timer is working as intended. This blinking behavior is caused by this blue capacitor connected to two resistors feeding into the threshold and the trigger pins through these two blue wires. Once the blue capacitor is connected to VCC, by powering on the power source, the capacitor is going to start charging. And when the capacitor is charged, a transistor inside the chip is going to be activated, allowing the capacitor to begin discharging through the chip's discharge port. And once discharged, the transistor inside the chip is once again deactivated, allowing the blue capacitor to start charging again through VCC. And this cycle repeats as long as the power source is turned on. The blue capacitor will charge, then it's going to discharge, charge, and discharge, back and forth, back and forth. That's going to vary the voltage being fed into the trigger and the threshold pins through these two blue wires. And both of those pins are connected to a comparator, and those two comparators set and reset a flip-flop inside the chip. And the flip-flop ultimately controls the output pin's voltage. So since the timing of the duty cycle of the output voltage, the output is controlled by the charge and discharge cycle of the blue capacitor, we can adjust the timings of the waves by varying the resistances of the two resistors and the capacitance of the blue capacitor.